How you get the most out of your PV system every day? This is the question we are asking us today in our today's webinar. I welcome you dearly, ladies and gentlemen, to our today's online session of how to get the most out of your sun every day. Together, we now want to speak a little bit about yield situations within your PV system and how you can overcome shaded situations. So in this webinar, I will going to show you some solutions that we offer from Fronius that you can cope with shaded situations on your roof and how you get the most out of your system every day. On the agenda today's first point is smart system design, and in this point I want to show you how you as an installer, as a system designer, can cope with shaded situation and what a smart system design should look like. Second up, I will talk about a shading solution that we offer from Fronius that you can overcome shaded situations on your roof. And third of all, we are going to talk about higher system efficiency and how you can do sector integration within your system. So let's start right away with the first point, smart system design. And therefore we have an online free of charge tool for you that you can use always for system designing your PV systems. So this is called the Fronius Solar Creator and you can find that on our webpage. Therefore you can smart system design each and every individual PV system. So whenever you have a new customer system, for example, with the Solar Creator, you have ease of use to integrate the cell design, the string design of the system, and later on also advance the system with sector integration like mobility, heat, and storage solutions. So with that, you have the possibility to get a whole overview about the system. You will get to know the own consumption values as well as the auto grades that you will get for a specific system. And at the end of the day, you will get out a report that you can directly use for your customer visits. First things first, for the Fronius inverter, it is called the Superflex design. And with our Superflex design that is integrated in each and every Fronius inverter, you have the ease of use that you can use a broad range of DC input voltage range. So with that, it is possible that you can freely decide how many modules you want to have on one single string and how to do your system design, especially when it comes to different orientations like east, west, and south orientation. Let me give you an example here with our Fronius Gen 24 and Gen 24 Plus series. We have a very wide DC input voltage range. For example, with the SIMO, with our three-phase devices, going from 18 volts up to 1000 volts of DC input voltage range. For the single-phase devices, for our primer devices, we are going lower, even low to 65 volts only, up to 600 volts DC. So this would mean that you can design a system even with only 3 modules on one string to make sure that you can even cope with very small roofs, for example, a small south-orientated roof. Yeah, furthermore, we have of course a high amperage range. So in this case, for the SIMO Gen 24 Plus for the three-phase device, we have an input voltage range of 25 amps on MPP1 and 12.5 amps on MPP2. So let's come up with a solution for shading, and I know that most of you guys cope with shading every day. First of all, let's talk about the causes of shading. So what can cause shading? First of all, of course, roof structures. If you have a chimney, for example, in the way, if you have snow or dirt like leaves on the modules, for example, also cables that are going through the roofs can be shaded causing. Yeah, how can you affect now the yield with shading, or what does the yield is being affected with? First of all, intelligent system design can help you coping with a shaded situation. So whenever you system design a new system, make sure that beforehand you build the system, you cope with shading to overcome the bad situations. Let's talk a little bit about a myth for shading. So a common myth out there in the market that still exists until today is that when you have a series connection of PV modules and one of the module is shaded, then the whole string is being affected and is lowered by power. However, this myth is wrong. This is not longer the case within PV industry, and the answer to that is the so-called bypass diodes. When you nowadays buy a PV module at the wholesaler, you most likely would get a half cell module with at least 3 bypass diodes. And the bypass diodes now help to overcome a shaded situation on a module. So you can imagine the bypass diode by just overjumping the shaded area of the module. So as we have here on the right-hand side of the graphic, we see a module with 3 bypass diodes. And when there is a shading situation, for example leaves on one side of the module, then only 1/3 of the module, since we have 3 bypass diodes, is being affected. The bypass diode, depending on the voltage of the area, will then get active to make sure that the current overjumps this area and is being bypassed by the bypass diode. With that, you have ease of mind that you can always have a shaded situation, no matter you have the possibility to overcome this shadow, and to make sure that the rest of your modules and even the rest of the shaded module, the rest areas, are performing at a good peak performance. So therefore you can prevent hotspots, you can overcome shaded situation, and as I said, the half cell modules with 3 bypass diodes, they are standard by now on the market, so therefore you will never have problems with shaded situations. However, we have 2 basic rules I want to give you today. First of all, avoid shading as much as possible. As you know, a shaded module will never deliver peak power that you want to have for your PV system. So whenever you have heavy shading, especially during peak days of the time, so for example on lunchtime, please make sure that you leave out the modules there. Problem is that with a heavily shaded module, the module will never deliver the maximum power that it is capable of because of the shade. Therefore, you can just omit modules that are being heavily shaded, and of course with the intelligent system design you can overcome this. However, we have a good solution for the shading situation, and we would not be Fronius if we don't have a clever situation for shading as well. And therefore I want to present to you today our Dynamic Peak Manager. The Dynamic Peak Manager is now an integrated software solution within each Fronius inverter, so no matter which Fronius inverter you buy, you will always get the Dynamic Peak Manager on board. The Dynamic Peak Manager now makes sure that you have highest yields within shaded situation and of course also with partially shaded situations. With the Dynamic Peak Manager you don't have a need of external DC optimizers anymore. How does the Dynamic Peak Manager now works? First of all, let's talk a little bit about the IV curve of a PV system. So in this IV curve you now see here this blue line, and this is the IV curve of an optimal not shaded situation. So in this situation the inverter will track to the global maximum power point, to the GMPP. And this is the maximum power where the inverter can regulate the system to it, voltage and amperage wise, to get the maximum power out of the system. For a normal unshaded situation, the IV curve looks pretty constant, so therefore it's not a big problem for each and every inverter out there on the market to find the global maximum power point. However, during shaded situations, and especially during partially shaded situations, the IV curve changes a lot. And this is what you can see down below on the red line and on the black line. Therefore, and this is the problem now, when shading occurs, the MPP point is affected, and actually there are existing then 2 maximum power points. First one is the global maximum power point that still exists. However, most of the inverters, they will regulate down to the so-called local maximum power point. And as you can see in the IV curve, the local maximum power point actually delivers less energy, less power that you would get with the global maximum power point. And the problem is, an inverter without the Dynamic Peak Manager would stay at this local maximum power point because he will track the IV curve down and will see, okay, the power is going down, and when he's tracking the voltage up, he will see, okay, the power is going down again. And therefore we have our Dynamic Peak Manager, and this algorithm will watch the whole IV curve from time to time to make sure that whenever there is a global maximum power point within the IV curve, the inverter will track to this global maximum. And of course there is a big deviation between GMPP and LMPP, and the inverter will always make sure to get the highest yield out of the system within this algorithm. So basically the inverter is doing exactly the same like you would have with an external DC optimizer, but we are doing this within the inverter without the need of having DC optimizers on the roof. We even calculated such as a simulation with the software PV Solar, and therefore we have a system design located in Germany. We had there 30 half cell modules from Trina Solar with 395 watt peaks per power, and we had a south orientation. We then connected that with a Gen 24 Plus 10 kilowatt device, and we then measured the losses occurring to shading. And we come to the solution that at an annual energy production of 14,485 kilowatt hours, we only had 34.7 kilowatt hours of annual losses. So that means that we only had 0.24% of losses, and they are neglectable thanks to the dynamic peak manager. So that means when using a Fronius inverter within the dynamic peak manager, you can make sure that you overcome shaded situations. Then I want to show you the real difference between the dynamic peak manager and if you're not using a Fronius inverter with dynamic peak manager. So what you can see here is a PV yield for one day without a dynamic peak manager. So in this case, we're assuming a shading occurs from 8:45 until 10 a.m. And now you can see the difference with the dynamic peak manager. As you're having losses in the morning hours, the dynamic peak manager will regulate the inverter to the global maximum power point and therefore will cut out 7% more yield within this day. So as you can see, the difference is there, and of course the end customer wants to have the 7% more yield throughout the day, and with the dynamic peak manager, with half cell modules, with free bypass diodes, you can be sure that you can use such a system. A big question that always arises for the customers as well as for the installers is why should I use or why shouldn't I use optimizers? So DC optimizers. And the question to that is relatively simple. Whenever you are installing a Fronius inverter with half cell modules and bypass diodes, please never use an optimizer. So there is really no sense in making an optimizer, a DC optimizer on the module whenever you're using a Fronius inverter because of the dynamic peak manager. So as you can imagine, the dynamic peak manager with the Fronius inverter is doing especially the same thing what a DC optimizer on the module does, but it doesn't do it on the roof, but it does it inside the inverter. And therefore you have the ease of use that your power electronics are inside the inverter and not on the roof, not on the modules. Besides that, and we calculated this thing also, you have a whole bunch of more DC connections within your system. So whenever you watch an inverter, for example, we then have here multiple modules within the case. And then we have, of course, a bunch of number of DC plug connections extra needed because of the DC optimizers. So in our case, for a standard system, we calculated an additional 61 plugs for the DC connection side because each and every DC optimizer needs to be connected to each and every module. So therefore, you will get a lot more DC connections, and of course, this is bad for safety and of course for service life. Yeah, furthermore, there is little to no limitation or less yield compared with a Fronius inverter with the dynamic peak manager. So whenever you're using dynamic peak manager, there is more or less no difference between a DC optimizer and the Fronius inverter. Yeah, furthermore, there's a high possibility of errors, of course, because as you can imagine, with the higher DC plugs, you have a higher failure rate, and then you are forced to go on the roof again, climb up there, and then exchange, for example, a DC optimizer. Nevertheless, of course, higher risk of fire because DC plugs can fail, as you know, and therefore also the risk of failure and fire occurs. Yeah, so sum this up about shading and complex roof. First of all, we recommend you, a good planning. So this is really key for each and every PV system. Please make sure that you get the most out of your roof every day by good and clever system design. With that, you have the ease of use to make sure that you can get the most out of your modules just by leaving out heavily shaded modules, and other modules that are partially shaded throughout the day, they can be coped with the dynamic peak manager. And therefore, we also recommend you to use half-cell modules with at least 3 bypass diodes, because then the dynamic peak manager can do its wonders, really can do its magic, and therefore make sure that you are fixed and finished for each and every shaded situation. Furthermore, within that, you have the ease of use to not use any DC optimizers on the roof, because then you have the advantage that you have fewer plug connections, a lot of fewer as we saw, and of course fewer components that can make an error or that can fail during service life. For the last part for today, I want to go into detail on highest system efficiency with our sector integration. And therefore, of course, especially in times where the feed-in tariffs are getting lower, customers want to make sure that they can use their own energy coming from the PV system. And therefore, we have a whole bunch of functionalities within the Fronius system that you can use for sector integration. Starting off with our DC-coupled high-voltage battery technology, you have the possibility to directly DC couple a high-voltage battery to the hybrid inverter. With that, you have the big advantage that you have the highest efficiency within the process, because the DC power that comes down from the PV generator can directly be fed into the battery storage without conversion losses. So that means that unlike with an AC coupled battery storage, for example, you don't have the necessity to exchange the power, so to convert it from DC into AC first, then from AC back into DC for the AC coupled battery storage. And then when you use it in the nighttime loads, for example, you need to change it back from DC to AC for the home grid. And with the high voltage technology on the hybrid inverter, you have the possibility to directly use the DC power coming into the battery system, and then under nighttime, for example, you want to convert it from DC into AC, and therefore you have minimal conversion losses. And this is what we get from most customers. This is most important for their systems, that they have minimal charging and discharging losses. Yeah, of course, another big advantage is the high charging discharging power. So whenever you have, for example, a bigger PV system, of course, the customer wants to make sure that the power delivered by this system is being fed into the battery system. And therefore, you need to make sure that you have a high charging and discharging rate with your battery system, because otherwise it can be that the battery system is not being fully charged at the end of the day, because lots of surplus are being fed into the public grid. And therefore, with our hybrid inverter, you have the ease of use that the storage is fully charged at the end of the day. So I have brought you here an example of a bigger PV system. And you see here the green area is what is being fed into the battery system. And this is because we have high discharging and charging power, in this case up to 7 kilowatt, for example, what can be fed directly into the battery system. If compared with a low voltage system, for example, the charging and discharging power will be lower. So in this case, for example, only 3 kilowatts over the day. And this would mean that at the end of the day, maybe the battery system is not being fully charged, because the power can't be translated into the battery system. And this would lead into return on investment losses, of course, for the customer, because he is feeding energy into the grid instead of storing it into his battery. Another big advantage of the Fronius inverter is now the so-called multi-flow technology. And this technology helps you as an installer to get ease of use for installation, and also later on for the customer. With multi-flow technology, he can be sure that his energy flows are always being taken to good use. First of all, we have, of course, with our multi-flow technology, the basic functionality of a PV system. So DC power can come down from the PV generator, can be fed into the battery system directly, or it can be converted into AC to being used by the household loads or being fed into the public grid. Second possibility is then to discharge the battery from the DC side and to convert it to AC for the household loads, or even to fed it into the public grid. Third possibility is then to charge from the AC side, so energy coming from the public grid, to charge your battery system whenever needed. And the most clever functionality and the most convenient functionality for you as an installer is the so-called AC coupling for a hybrid inverter. So that means that you always good to go with a third-party inverter, with a small hydropower plant, or even with a wind turbine, so whatever is installed at the customer sites. You can use the AC power coming from a third-party device or a second inverter to use this AC power to charge the battery system or to operate the energy management, for example, for mobility and heating solutions. So this would mean that all you need to have, for example, is a Fronius smart meter at the feeding point, and then you will get the information of what the alternating AC source is delivering at the moment, and the hybrid inverter will get this information and will process the energy either into the battery system or for other energy management purposes. And the ease of use for this system is that you don't need an active data communication between the third-party inverter and the Fronius inverter. So with that, all you need to do basically is to connect the AC cable and to make sure that there is a Fronius smart meter at the feeding point. And from this time on, the hybrid inverter, the Gen 24 Plus, can take the energy from this AC source and cope with it and work with it within the system. This system is even possible without PV modules on the Gen 24 Plus, without PV modules on the hybrid inverter. So to make sure whenever you have an upgrade system later on, when the customer wants to advance his system, you can make sure that with a hybrid inverter you have ease of use by just AC coupling the hybrid inverter and use the existing energy of the existing inverter, for example. However, we always recommend you to install PV modules, PV generator on the Gen 24 Plus, because with that you have the highest possible efficiency by charging the battery storage directly with the DC side. Last but not least, I want to give you an overview about the easy sector integration that you have with the Fronius system. First of all, you have the possibility to not only cope with the sector electricity and storage, but also with the sector integration of mobility and heat. So whenever you have a customer, for example, with a heat pump or with an electric vehicle, you have the ease of use from Fronius that you will get a solution out of one hand, so to say, that we comply the customer for the energy transition. So first of all, we have the ease of use, for example, for PV module, first of all, for the inverter, for the high voltage storage, for the e-mobility, and then for the thermal storage. So no matter if you want to have, for example, a thermal storage within the household, you can easily do that by just an electric heating rod and our Fronius on-pallet. Or for example, you can even control a heat pump to generate hot water or to supply the heating system. Furthermore, of course, you have the possibility to do backup power solutions. So whenever there is a backup power solution needed, you have the possibility of doing so with our hybrid inverters. Since it doesn't make sense to only cook our own soup, we have the approach of open interfaces at Fronius. So therefore, we want always watch to have a good compatibility with third-party manufacturers. And on this page, you can now see a little sum up of the different manufacturers that we are compatible with. So with that in case, we have different applications that we can use for. So for example, you can control a heat pump, an external heat pump, over, for example, our digital I/Os. We also have direct communication with some of the manufacturers about Modbus TCP/IP, so over our solar API calls. And of course, the inverter always have LAN and Wi-Fi to make sure that you have an internet connection, network connection to SolarWeb. So with this open interfaces, we want to make sure that we can integrate third-party devices. So whenever your customer, for example, has a smart home integration, an existing heat pump, or wants to use electric charging stations, you have the possibility to use our open interfaces with the inverter to make sure that you are not only a closed loop system, but you have open interfaces to all other manufacturers as well. If you're interested in our compatibilities, please check out our compatibility list of the Gen 24 Plus, and there you will find a whole setup of this. Yeah, I hope this webinar was informative for you. If you want to get more information on these topics, I would recommend you our Fronius YouTube channel, of course. Please watch more videos about different topics, different solutions. We have there different solutions for you about the e-mobility sector as well as heating purposes and storage solutions. Whenever it's possible for you, please also use our webinars and how-to videos if you want to, and there you get more information about the solutions. Okay guys, I wish you therefore best of luck with your next installations. Please always remind you of smart system design, of course, with the Fronius inverter. Make sure to system design your system, and afterwards make sure that you get a sector integration for the customer to make sure that you get the most sun out of every day. I wish you lots of luck with that. See you the next time here at Fronius. See you and goodbye.